Now that we have a fully functional template, let's extend it with a core functionality just like we discussed last time. First, we'll add a final bit of code to our user form to prepare the worksheet. We'll add a place and title for the number of core cells, the cell lengths in X and Y, and the core position in X and Y as well. The core center will be in absolute coordinates and will represent the geometric center of the core in the X, Y plane. For simplicity's sake, we'll assume that additional core cells will be aligned with the X-axis. This means that if we input additional cells, they will be put in alignment with the X-axis, or, if you want, in the horizontal orientation. And let's run this code just to prepare the worksheet as usual. Okay, everything is ready to start working. First, we'll add a new procedure called Add Core Walls. This procedure is what will add the bulk of our functionalities, namely, the core walls themselves. The function header will be quite long because of all the input parameters it will receive. We'll need the SAP 2000 model as always, the number of stories, story heights, number of core cells, cell X and Y lengths, and core center coordinates in X and Y. Next, we'll declare a bunch of variables for the indices, corner coordinates, current coordinates, and some arrays for coordinates, as well as an area name to assign created core walls to the core group. More on that in a bit. Let's declare a new core group with the setGroup function. Then, we'll calculate the corner coordinates for X and Y. We'll be using these as sort of origin coordinates to place our area objects. We can calculate the corner coordinate, in this case the lower left corner, if we think of the XY plane projection, by simply subtracting half the cell length for the Y coordinate and by subtracting half of the total core length for the X coordinate. Right, next we'll resize the coordinate arrays for the X, Y, and Z coordinates and set the starting Z coordinate to 0. Let's now write 2 for cycles. The first cycle will be to iterate through stories, and the second one will be to iterate through core cells. Let's start with the Z coordinates. This will be quite similar to the basement wall cycle where we'll use the current Z coordinate for the first 2 points and add the current story height to the last 2 points. Next, we'll be doing something kind of weird. Instead of filling each cell completely, we'll be adding 2 walls at a time in an L shape. Then, after all core cell walls have been added in a floor, we'll close out the final cell with an additional Y-aligned wall. For the X and Y coordinates, we don't need to worry too much about the order of the points as we're not concerned with the normal vector of the area object pointing inwards or outwards. First, we'll do the Y-aligned walls with a constant X value. Then, we'll do the X-aligned walls with a constant Y value. After we add an area object, we'll use its name to assign it to our core group. After all cycles have been completed, we'll then add the final Y-aligned area object and assign it to the core group. Okay. Now all we need is to increment the current height and call our function from the main application function. We'll call our new function in between where we add the floor slabs and where we divide said slabs by cookie cut. We're doing this because we want our floor slabs to take the core walls into account when we're performing the cookie cut division. Let's call our function only if the number of core cells is greater than 0. Okay, we're ready to test out our code as usual. Let's just fill our cells with some valid values. Remember that we don't really have a lot of user protection in our code, so we're responsible for inputting correct data. Again, we could add these user protections, but to keep our code simple and since this is only for demonstration purposes, we'll leave it up to anyone who wants to extend this code in their own time. Alright, let's test out our code. Great! Everything went okay. Notice also that, since we're applying restraints in a somewhat generic fashion, the bottom points of the core were also assigned restraints, just like all other points at the base level. But we're not quite finished with this. If we look around for a bit, we can see that, even though our core walls were added, the floor slabs we created do not have openings in them for the core. We'll tackle this in the next and last example, but, for now, let's take a look at how the core code is not really protected. Let's place the core quite obviously outside the building and see what happens. This is what we mean when we say the code is not user-proof. In a serious software development environment, software developers must anticipate any scenarios in which a user does not use an application the right way. Right, in the next step of our course we'll be clearing our floor slabs to make sure we have a core opening on every floor except the last one. We'll also be adding section cuts of our core elements and extracting results from them.